When we are working with surds, it is easier if they are not on the bottom of fractions. So rationalising the denominator basically means getting rid of all the surds on the bottom of fractions. These are the 4 examples I'm going to work through to show you how we do this. The first one, 1 over root 2. Now, if we're going to multiply a fraction by anything, there is only one thing that we can multiply it by that will not change its value, and that is by 1, because 1 times anything does not change the anything's value. So what we're going to do here is we're going to multiply this by root 2 on the bottom, the same as the surd we already have, but in order to make it a value of 1, we're going to put a root 2 on the top too. So this fraction here, root 2 over root 2, has the value of 1. So by multiplying by 1, we are not changing the value of our original fraction. If I now multiply this out, we've got 1 times root 2 over root 2 times root 2, which is root 2 squared. The square root and the square cancel each other to give us just 2. So what we've done is we have rewritten our fraction in this form, where the surd is no longer on the bottom, it's no longer the denominator, it's now the numerator, it's on the top of the fraction. So we have rationalised the denominator. Our new fraction has exactly the same value as our original fraction, it's just written in a different way. The second example, root 5 over root 6. I'm going to work in exactly the same way. I'm going to multiply by a fraction which is going to have the value of 1. It's got to have root 6 on the bottom here, so I must put root 6 on the top to keep that as a value of 1. If we multiply this out, we've got root 5 times root 6 over root 6 squared. And this is root 5 times 6 over the 6 squared and the square rooted. The 2 cancel and we've left with 6. And this becomes root 30 over 6. Now because the square root of 30 doesn't have any square numbers as factors, I can't break this down and simplify it any further. So that is our new form of root 5 over root 6, but the denominator has been rationalised. Our next example uses a fraction which is a bit more complicated, 1 over 6 minus root 2. And what we're going to do here is we're going to use the difference of 2 squares. Now the difference of 2 squares means having the conjugate of this on this fraction. The conjugate has the same 2 numbers, but the sign is the opposite. So we've got 6 plus root 2. And in order to keep this fraction with a value of 1, we must have exactly the same on the numerator, so 6 plus root 2. Now over on the side, I'm just going to remind you how these denominators will multiply out, our difference of 2 squares, which are our 2 conjugates multiplied together. Now they are multiplied because the fraction line effectively acts as a bracket. So it means that all of that is being multiplied by all of that, which is the same as writing them in brackets. Now if I multiply this out, we've got 6 times 6, 6 squared, 6 times root 2, 6 root 2, minus root 2 times 6, which I'm going to write with the integer first, so minus 6 root 2, and minus root 2 root 2, which is minus root 2 squared. Now you can see that these 2 terms are the same, but the signs are the opposite, so they will effectively cancel each other out. And what we're left with is 6 squared minus root 2 squared. This is our difference of 2 squareds, which is what we got by multiplying our conjugates. The difference is the minus. The 6 and the root 2 are both squared, and they are our 2 numbers from our conjugate brackets. And the nice thing about this is it always works out to be an integer value, which is why we use it. Now root 2 squared is just 2, and we get the value of 34. So let's now use this over here to work out our fraction. So we've got 1 times 6 plus root 2 on top, and the denominators multiply out to give us our difference of 2 squares, which I'm just going to write as 36 minus 2 to start with. So we've got 6 plus root 2 on top divided by 34. And that is our original fraction with the denominator rationalised. Our fourth and last example is root 2 minus 1 divided by root 2 plus 1. And again, we are going to use the difference of 2 squares. We're going to look at the denominator and write the conjugate. Remember, the two numbers are the same, but the sign is different. And in order to keep this fraction with a value of 1, we have to write the same for the numerator. So we've got root 2 minus 1 times root 2 minus 1 over the difference of 2 squares, which is our root 2 squared minus our 1 squared. Now let's multiply out the top. We've got root 2 squared. We've got root 2 times minus 1, which is minus root 2, minus 1 times root 2, which is another minus root 2, and minus 1 times minus 1, which is plus 1. All divided by root 2 squared is 2, minus 1 squared is 1. So root 2 squared is 2. We've got minus 2 root 2's and plus 1. Over 2 minus 1 is 1. And we can collect our integers together. So we've got 2 plus 1 is 3, minus 2 root 2. And because it's over 1, we don't need to write that. So this here, 3 minus 2 root 2, is our original equation with the denominator rationalised.